Okay, guys, welcome to our class recording in progress. To our class Wednesday, February 2nd, 2022. I just noticed the comment of Austin. Thank you, Austin, that some people were having ECE in person just now. I'm assuming they couldn't find a place to get online on time. Okay, this is a valid comment. Please remind me at the end of the class to talk about this. We might like postpone the start of a class for 20 minutes or so to give them time to move to a place that they can put their headphone and join the class. Okay, I will share my screen now to start with my recent announcement. Can you see my screen? Okay, sounds good. Okay, thank you, guys. So I received multiple emails. It seems that those students who are asking, because we talk about this multiple times in the previous lectures, about what, since the beginning of the course, it's clear in the course outlines, what are in person and what are online. Again, the lectures every Wednesday and Thursday would be online via Zoom. Recording will be posted in the YouTube channel for the course. The tutorials, we mentioned that some students send me what are the topic will be covered in tutorials every week. I never said every week. Even in the course outlines, we mentioned that we only have 4 tutorials through the term. The course does not require like a weekly tutorial. Even the department they did not provide a TAs, only 1 TA for this a huge number of students. Even from the past, since Professor Essex or before Professor Essex, Dr. Ali Nassif was teaching this course, it's always like 4 or 5 tutorials, some terms 3 tutorials. But in the last 3 years, we like used to have 4 tutorials per term. And that's more than enough. If you have any inquiry, you can ask the TA and meet him in person or via email or via Zoom or myself during office hour, which is immediately after our class. So, and you have the link in the course outlines and in the overview page. Here is the link for the office hour. It is every Wednesday from 12:30, or if these times is not suitable for you, you can like send me an email and we can arrange a time that's convenient for both of us. So so tutorials will be conducted in person. We don't have the material and cameras to record these classes and upload it online. So since it's in person, there is no recording will be posted about tutorials. Tutorials normally will answer your question, inquiry about the exam or about the assignment. If you have any question, if you have any difficulty to answer certain question or something, you can ask the TA and he would be more than happy. If there is no question, the TA also, I provide him with some problems and the question to solve it in the class in step by step with you guys to clarify some concepts that you might miss or need some more clarification to understand the concept. So the first tutorial will be from 8:30 to 10:30 Friday, on a Friday, and we have announcement on this that it would be in Friday, February 18. This session will answer a question related to assignment 1 and midterm exam topics. However, we will cover till that time more than the midterm material. Once we're done with midterm material, I will let you know that I will make an announcement. This is the material will be covered in the midterm exam. Till now, we are still in the midterm material. So we didn't reach to the point that I will tell you that we are done here for the midterm material. So everything that we took from the beginning of the term till now until today, this week material and part of next week material are covered by the midterm. So next week, I'll let you know that this is the material that would be covered, that will be covered in the midterm. And to know, in this course, it's difficult to split the material that the final exam material, because we are building concepts one after another topics, so they are all connected. So the final exam will cover everything since the beginning of the term till the end of the term. Also, once we reach to the final exam, I'll give you like a guide to study guide. Okay, so second tutorial, these dates are tentative for the assignments and for the final exam. As we know the final exam period, we don't know which day will be our exam. I'm not sure if Western announced this or not yet for the final exam. And it's designed to be in person. So midterm, tutorials, final exam will be in person. The TA and other proctors will manage and run the exam. I'll put the question, I'll give them the solution, I'll give them the rubric, how to mark the exam, but I will not be there. So I hope these things are clear for all of you. So the second tutorial session, I'll try to meet these dates exactly. However, if something changed, we could change it. But it would not be like earlier or later in long period of time. It would be a very short period. It might be a few days, plus minus. So the second tutorial session would be on Friday, March 2022, and this would be immediately before the deadline of assignment 2. It would be March 21. So if you have a question, you will have enough time to answer your assignment. If you have a question with regard to assignment, then you will go to attend the tutorial in March 18. So you have 3 days to answer what you missed in assignment 2. For the group, the third tutorial, which will discuss the topics of group assignment, that would be Friday, April 1st. And the deadline is Monday, April 4th. Then the final exam revision will be on the last day of the term, which is Friday, April 8th, because the exam, they make the April 9 study day, which is Saturday. Then the exams will start on April 10th, on Sunday, April 10th, the exam period. And Western used to have exam on Saturday and Sundays. So this would be like revision for final exam. However, that week, Wednesday and Thursday class also would be revision classes. Or if we finish the material before, the week before would be a revision class. I'll do this revision by myself, but this tutorial will be run by the TA. That will be facilitated by the TA. So assignment 2 will be released on Friday, March 4. So assignment 1 this Friday, after 2 days. I will release assignment 1, and the submission deadline will be Tuesday, February 22nd, which is the day after Family Day, second day of reading week. I should put the deadline before the reading week, but I want to give you more time, guys, to do the assignment. It is a simple assignment, easy, straightforward. So I'm sure most of you will submit before at least like a week before the deadline. Mostly students submitted their work a week ahead. But please don't be late. There is a late penalty. Don't lose marks. Because after 11:55 on February 22nd, you will be considered as late. So please, you have more than enough time to the assignment. Assignment 2, also it will be due on March 21st. And the group assignment would be due on April 4th. Exams, kindly note that midterm and final exam will be conducted in person, no exceptions. This is by the university, not me, guys. Unless the province, we hope not, decide to back to online. At that time, it's a different story. It's beyond my hand and your hands. But Western put all plans based on in-person learning or blended learning. So our courses are blended. Lectures delivered online, tutorials, exams in person. So I hope for everybody to be a successful, to have a successful term with the highest marks ever. Also, guys, if you have colleagues and you know them in our class, please encourage them to attend. Encourage them to attend. Because, you know, what I see, like today is 43, normal is 55 to 56 students attend, which is 32 to 33% of our class population, which is 161 students or 160. I think one student dropped the course. So even the views in YouTube channel, I try to combine both. So I would assume that those who attend the class physically, they didn't see the YouTube. However, I believe most of them, they watch the YouTube, but the number of views is also 30, 40. It's not a commercial YouTube channel, it's education. So I'm not concentrated in number of subscribers or views. I'm not a YouTuber, but these numbers give me like some indication that how many students, even they could not attend the class. How many students watch the video if they could not do that? But it seems to me that you guys who keep attending the live Zoom sessions or lectures, the same group, they are watching the videos. What the remaining they are doing, it's their call. I don't have like, I didn't put like a class participation or make the attendance to the Zoom mandatory. I can't take attendance, you know, Zoom give me the just one click, I'll get the report of attendance. So please advise or encourage your colleagues to attend the class. This is for their benefit. And it's their call. So, any question about our plan till end of the term? What do we have? Don't be shy, guys. Just unmute your mic and go ahead. No questions? Do we have any class exercises or a question for today or no? Okay, Jenny, you are the first. Please share your screen. Yes, I don't know why. I don't know why. Since when it stopped? Or just now? Okay, thank you, Brandon. Thank you for this. We will see. Once the class is done and we will see the video, we'll see if there is something missing. We will see what to do. Again, we talk about the pumping lemma to prove that the non-language or the non-regular language is not regular. How we'll do that? We'll take the properties of regular language, and if we prove that one of these properties is not there, then the language is not regular. So how to do that? We use the pumping lemma. What is the pumping lemma? If L is a regular language, then for all string S belongs to L, where the cardinality of S is greater or equal to P. What is P? Can you see now? Okay, thank you, guys. So what is P? Is called pumping length. Then S can be divided into 3 parts. The string S will divide it to X, Y, and Z, where X to the power, Y to the power I, Z belongs to L, to that language, for I greater or equal to 0. The cardinality of Y is greater than 0. Y could not be an empty or 0 length. The cardinality of X and Y should be less or equal to the pumping length. Should not be greater, could not be greater. The pumping lemma concept arises from the pigeonhole principle. What do we mean by that? That if I have n holes and I have n plus 1 pigeons, and these pigeons occupy the holes and no pigeon is outside of the holes, that means that there is one pigeon that contains more than one pigeon. Assume that to move that to the computation and to the automata theory, that any string S belongs to L defines a computational path through the automata. So assume that we have a DFA or an FA with P states. We have like 5 states. If we feed in a string of length P or greater than P, like a string of 6 symbols, when the language could accept, the language would accept if there is one of the state that can take or repeat it more than once, which is the loop concept or a cycle. And if there is a loop, then we could build a string that repeats this loop as many times as we want. So this is how we took the principle of pigeonholes. These, like the repetitive thing at the state, it is used in NFA or DFA, and this could give us a string that has a length more than the number of states. Is that clear till here? Questions? So by pumping, we are talking about pumping up a string, like inflating a balloon. Each string of regular language, no smaller than pumping length, has a middle portion, then can be pumped. This middle portion, we could pump it. By pumping it, we might that this middle portion can be, here there is a typo, can be repeated arbitrarily many times, and that the result will also be in the language. Ultimately, we are still talking about looping, so looping lemma may be a better name for it. However, all books, everything call it pumping lemma. Visualization of the pumping lemma. The pumping lemma says if the language is regular, then for any string long enough, the computational path will have 3 parts: X, Y, and we can repeat it, then Z. The idea here is what there exists a segment of the computational path Y, which start is S middle. We call it S middle. And result to S middle that can be repeated or pumped arbitrarily many times before finally continuing into the accepted state to reach to the final state. What is the strategy to prove that this language is regular or non-regular? If a regular language must have this middle repeated Y portion to show L is non-regular, we have to show that this Y portion is non-present in L. To do this, we proceed with a proof by contradiction. What is the meaning of a proof by contradiction? You can go to Wikipedia and see. We will have a separate class about proof techniques, which is 5A, handout 5A. At the beginning, what do we mean by contradiction? It's by assumption. We prove by assumptions. Assume L is regular. Whatever I have the language in the question, the first assumption is to assume it is a regular language. Because we said how to prove, we will assume it is regular. If there is one property is not there, then it's not regular. Otherwise, it's regular. So we would assume that L, the given language, is regular. Use pumping lemma to guarantee that all strings S belong to L that are long enough that the cardinality of S is greater or equal to P can be pumped. If I give you empty string, can you pump it? No. Find some string S belong to L where the cardinality of S greater or equal P and show that it cannot be pumped. The third thing, we have to show that this string could not be pumped, then we prove it's not regular. Showing a string that cannot be pumped. In order to show that the string S belong to L cannot be pumped, we must consider all possible ways that S can be divided into parts X, Y, and Z, and for each of them find some I greater or equal to 0, such that XY to the power IZ is a string that is not in the language to produce our contradiction. Recall our string S, the one we use to find a contradiction. We don't actually pick a specific string S, but leave S abstract and focus on the general structure form. We don't assume we know what pumping length P is. This is your question. P is unknown number. We simply define our S such that the cardinality of S is greater or equal to the assumed P. We don't examine all possible ways to partition the string S into 3 parts. Rather than S is of a general form, we look at all the possible cases that S could be partitioned. First example, we will have many examples. Don't worry. I know it's a totally new question for all of you. Recall our language L, our previous example, 0 to the power n, 1 to the power 1, where n is greater or equal to 0. Prove that L is non-regular. Proof. Assume L is regular. This is the first assumption. Second assumption, let S be a string on the form of 0 to the power P, 1 to the power P. Clearly, S belongs to L and the cardinality of S is greater or equal to P. We don't know P or the cardinality or anything. let S equal X, Y, and Z. If L is regular, as we have assumed, then as per the pumping lemma, it is also the case that X, Y to the power IZ belongs to L for all I's equal, greater or equal to 0. So normally we negate this. So X, Y to the power IZ belongs to L for all I's greater, or where I is greater or equal to 0. Show S cannot be pumped. So if we assume that we could not pump S, then the language is not regular. How we can show that S cannot be pumped? Now we examine how we can prove S equals 0 to the power P, 1 to the power P cannot be pumped. To do this, we consider all the possible relevant cases of partition S into X, Y, and Z. Okay, let S equal X, Y, and Z, and by your definition, S contains an equal amount of zeros and equal amount of ones. Recall from our pumping lemma definition, we require that the cardinality of Y is greater than 0 and the length of Y, XY is less than or equal to P. Case 1, Y contains all zeros. What happens if we pump Y? Let S prime equal X, Y to the power YZ if I greater than 1, and since Y greater than 0, then S prime XY to YZ, the process of pumping adds some non-zero amount of zeros to S prime. This means that now S prime contains more zeros than ones. If we said Y is zeros, so if we pump the zeros, then we will have more zeros than 1. However, by definition, that in our language that they have equal number of ones and zeros. So this means that now S contains more zeros than 1, meaning that S prime not belongs to L. Similarly, if we consider I equals 0, we have S prime XZ. We have taken away zeros, and thus S prime contains fewer zeros. Another case that you might take, because this assumption, I leave it to you. You are the one who take the cases. If we said that Y contains all ones, similar to case 1, if we have S prime XY to the power IZ and I is greater than 1, then we are adding ones to the string. If we have I equals 0, we are removing ones from the string. Either way will not have an equal number of zeros and ones. So S prime not belong to L. Case 3, Y contains both zeros and ones. There are 2 subcases to this to be considered here. Case 3A, if Y contains an unequal amount of zeros and 1, the argument here is similar again to the previous 2 cases. So I might have fewer 1 or fewer zeros. But if they are contained an equal amount, this case is different from case 1 and 2 and 3A, since pumping Y in this case would add or remove an equal amount of zeros and 1. And with this assumption, we cannot prove that the language is not considered. So even though S prime contains the correct number of zeros and 1, they are out of order. So once again, we have S prime is not belong to L. Why? Because here I'll have Y to the power I, Y times 0 to the power X, 1 to the power X, 0 to the power X, 1 to the power X, I times. So our goal was to prove that L 0 to the power n, 1 to the power n is greater than or equal to 0 is non-regular. To that end, we started by assuming that L is regular, then we choose a string that 0 to the power P, 1 to the power P, where P is the pumping length, and the cardinality of S is greater or equal to P. And so to show it cannot be pumped. From there, we consider all possible ways to partition S, X, Y, and Z, and for each case, we showed the existence of some I greater than or equal to 0, for which S equal xy to the power iz is not belonging to L, then L is not regular. What does that all mean? Well, if L was regular, then as per the pumping lemma, all string in L must have this pumpable Y portion. Yet by showing that our string here, there is a typo string S, cannot be pumped no matter how we slice it. We have proved that S does not have the requisite property to L to be in L, yet clearly S is in L. This is contradiction. Therefore, then we'll have to mention in your answer, by contradiction, L is not regular. Questions? What do you mean, Ahmed? Or you just joined the class? Questions, guys? Okay, now I'm sure that some of you or most of you, they have some question in their mind. So with the first example of pumping lemma using the slide, it is important for you to understand exactly what it proves or does not prove. I found a string in my language and showed that for all possible ways of partitioning the string into 3 parts, I could pump it such that the resulting string was not in the language, what I have proved. By way of contradiction, you have proved that the language is not regular. Another question you might have in your mind. I found the string in my language and showed it could be pumped for some or even all ways of partitioning it. Does that prove anything? No, because it could mean one of 3 possibilities. The language is regular, in which case all strings are pumped able, or the language is not regular and there exists a string in the language that cannot be pumped, but you just haven't found one yet, or all the string in the language can be pumped, yet the language is non-regular. Indeed, the language do exist, and you would require a different proof technique. We call it Mayer-Nerod theorem. This theorem, however, is outside the scope of this course. If you want to read about it, just click here and read about it. Pumping lemma summary. In summary, pumping lemma for regular language is the fact that all sufficiently long string in a regular language contain a substring that can be repeated arbitrarily many times and is usually used to prove by way of contradiction that certain languages are not regular. Just give me a sec, guys. Okay. Finally, if the pumping lemma feels complicated to you, and it kind of is, I'm sure, you may enjoy reading this blog post, I hate the pumping lemma. So you read a lot of things that sometimes it might be funny, sometimes it would help. However, we'll continue tomorrow. in pumping lemma examples, how we will solve questions with multiple examples. We will repeat the first example that we have today, and we have example 2, example 3, example 4, and I hope these 4 examples would help you to understand the concepts and how we would solve these things. If you have any questions, is it necessary to prove the string cannot be pumped for all ways? It can be. No, if you just slice it in a way and you prove that this does not belong to the language, that is done for me. Tomorrow you will understand more how to prove and how to solve the question, guys. So just one case, if you prove that, if you like split your string X, Y, and Z and you choose Y from the first occurrence that it's not belong to L, that is done. Don't continue with other cases. But I show you in the handout all cases, but in the exam with the first case, done. You are done. You answer the question. Okay. There's one student raised his hand. Tony, go ahead.
Yes, last class you asked a second question about like show a DFA for L where like in language 0 and 1 that the case last bit is 1. I was wondering if you could please go over that question. I could share my screen.
Yeah, share your screen, please.
Yeah, so this was the second question you asked. I was wondering if you would be able to go over it.
Yeah, this is the second question for volunteers. Yes, now I remember. So this was the first question. This is the second. So do you want to solve it for students?
I wasn't able to. Like I got
you
stuck.
wasn't able. Okay, who answered this question? Go to show your colleagues the question. Show that for each DFA for L, LK where W belongs to 0 or 1 star, the kth last bit is 1. So to draw a DFA for this, does anyone solve it? No one solve it? Okay. So tomorrow at the beginning of the class, Tony, if anyone wants to solve it, we'll solve it. He will solve it or she. If not, I will solve it. Okay. Thank you, Tony, for bringing that in.
Thank you.
If you don't have a question, you can leave. If you have a question, you can stay. Okay, Hisham, do you have a question? Longi, Austin, Jenny? No? If you have no question, then okay, for those, thank you, Austin. For those who could not make it, because they will have, tomorrow we'll talk about it. If we like delay for tomorrow class, you know, it's 1 hour, so I cannot delay it. But for Wednesday, we can like delay it like 20 minutes or so. So we can start like 20 minutes later to allow them to go to a place that they can put their headphone and attend the class. So tomorrow we'll discuss this with all colleagues. Please also, Austin, remind me tomorrow. It would be appreciated at the beginning of the class. Okay. Thank you. Thank you, Austin. Any other question, guys? Okay. I'll end the class and see you tomorrow. Bye for now.